question says, find the acceleration of the block of mass m in the situation shown in the figure. All the surfaces are frictionless and the pulleys and the string are light. So now let us assume that this block is moving down with an acceleration of a, and this block is moving up with an acceleration of a dash. Now we can mark it an mg force acting in the downward direction, and since we know that the angle of the wedge is 30 degrees, so a component mg sine 30 degrees will be acting along the wedge in this direction. Let us assume that the tension in this string is T, so obviously it will be 10 over here also, and hence a 2T tension is present here. We are not mentioning the normal and the other component of the mg forces, as we need to work only for the acceleration, which will be obviously in the direction of slope of the wedge only. So now let us start with making the equations for the block of mass m. Now we can say that mass into acceleration is equals to mg sine 30 degrees minus t. Now also we can write it as ma is equals to mg by 2 minus t, marking this equation as equation number 1. Now moving on to the block of mass 2m, we know that a 2 mg force is acting in the downward direction. So framing the equation for this block, we can write 2m into a dash is equals to total force in the direction of a dash, that is 2t minus 2mg. Cancelling the factor of 2 on both the sides, we get ma dash equals to t minus mg, marking this equation as equation number 2. Now by the pulley equation, we know that a equals to twice of a dash, that is a dash is equals to a by 2. This is because the acceleration of this string is equals to 0. Now putting this value of a dash in equation number 2, we get ma by 2 equals to t minus mg. Now if we mark this equation as equation number 3 and let us add equation number 1 and equation number 3, we will get 3 by 2 ma equals to mg by 2 minus mg. Cancelling the factor of m, we can say 3a over 2 equals to minus g by 2. Cancelling the factor of 1 by 2, we can say that acceleration is equals to minus g by 3, which is the answer for this question. Now we are getting this acceleration with a negative sign. This implies that it is actually in the opposite direction to what direction we assumed initially. This means that this block of mass m is actually accelerating in the upward direction. If initially we would have taken the acceleration in the upward direction, that is along the wedge in the upward direction, then it would have come automatically positive. So there is no influence of whether we take acceleration to be in downward direction or upward. We simply have to put the plus and the minus signs accordingly.